Well, we're at the 10:30 mark, and I think we'll kick things off and get things going. So, thank you all for coming and coming to this workshop, the Engineering Technology STEM Educator Workshop. Hopefully, you're in the right spot, and if you're not in the right spot, I think you'll enjoy it anyway. So please stay and take it all in. So we've got our Normandale team here. I'll introduce them a little bit. Really talking about strategies for teaching technology through telepresence for STEM workforce preparation. That's a lot and a mouthful, but I think you'll find that Nancy and Tom are going to really share some interesting ways that they've been able to achieve this and really support some of that industry preparation. So there's some pedagogy here that you're looking for, that you might be looking for in telepresence that they're going to be able to share. So I'm Jason Bruns. I'm the director of the Minnesota State Engineering Center of Excellence. And again, I welcome you all for joining us today. And I also want to thank our speakers and our representatives from Normandale College here, Nancy and Tom. Couple housekeeping things here. This is recorded to make sure that you're aware of that, as well as there'll be a survey coming out. What we would like you to do is populate that survey. That helps us create new programs and bring new programs, and really helps to give you some of the things that you're looking for. And I can work, our center can work towards finding those partnerships across the system to help bring you some of that education that you're looking for, professional development. And then also the video would be available on our website as well for you to be able to review and look over again and check it all out. As far as professional development, this is also eligible for professional development. All you have to do is go to our website, engineering.msu.edu, and you can contact me directly via an email, jason.bruns, B-R-U-N-S, @mnsu.edu. Or, you know what, if you can connect with on how you got into this program, you just flip an email to our team and they'll get a hold of me, and then I can get that out to you as well. Give me a little bit of time on that. It takes a little bit to put that together, but more than happy to support your professional development. And this is really what we're trying to do here as well. So what I'd like to do is now introduce our featured speakers from the wonderful Normandale campus. Nancy Luigi is Chair of Engineering Technology Programs Department at Normandale Community College in Bloomington, Minnesota. She graduated from North Dakota State University with a bachelor's degree in electrical engineering and the University of Minnesota, Twin Cities, with a master's degree in electrical engineering. She worked in test and quality engineering positions at Honeywell, Angion, and Boston Scientific in the Twin Cities. At Normandale, she has taught quality practices and measurement and introduction to vacuum technology courses. She currently serves as a principal investigator and the co-principal investigator respectively for Normandale's National Science Foundation, Advanced Technological Education, DUE 1700624, with Tom Johnson being a co-PI, and also working on the grant project awards, number 2000454. So along with that, our other presenter today, which we're proud to have, is Mr. Tom Johnson, also at the Normandale campus. Tom is an adjunct instructor in the vacuum technology department at Normandale Community College in Bloomington, Minnesota. He graduated from the University of Minnesota Twin Cities with a bachelor's degree in aerospace engineering and mechanics. He has spent most of his 30-plus year career in design, manufacture, and sales process instrumentation. He currently owns a manufacturer's rep agency, EngineeringSales.co, which distributes process instrumentation, valves, and controls to a wide variety of industrial applications. So with that, I'm going to stop sharing, and I'm going to let Nancy take over here and go from there. So what I will do is at various times, I will go ahead and put her presentation into the chat so it's readily available for you. So I'll do it in the beginning here, and then I'll do it again at the end as well. So Nancy, I'm going to let you take it away.
Thank you, Jason. Good morning, everyone. Thank you for joining this workshop today. And thank you to Jason and the Minnesota State Center of Excellence for Engineering for inviting Normandale's Vacuum and Thin Film Technology program to present at today's workshop. As Jason mentioned, I'm Nancy Lawaji. I'm the chair of the Engineering Technology programs here at Normandale Community College. This department actually has two programs in it. There's the Vacuum and Thin Film Technology program, which we'll talk mostly about today, and then Computer Technology. Both of those programs are two-year AAS degree programs. Both programs also have certificate options. We'll talk a little bit about that as far as the Vacuum Tech program is concerned too. I'm joined by colleague and VAC Tech instructor, Tom Johnson. Tom and I, as Jason noted, are both on the PI team for the NSF ATE project awarded to Normandale. And it's the DELIVER project. That's an acronym for Distance Education and Learning in Vacuum Technology for Employment Readiness. We received that award in 2017. We're actually in what they call a no-cost extension. This is our 5th year with the award. It's been a very productive project, and we're really excited to share some of the things that came out of that project with you today, too. So just as an orientation, I want to make sure people know about the program. So what is our program? I mentioned that we have the Associate of Applied Science in Vacuum and Thin Film Technology, and that's a standard 2-year, 60-credit degree program. We also offer 2 certificates that are essentially subsets of the AES degree. One is called the Vacuum Maintenance Technician Certificate, and that's 28 to 29 credits. And then we also offer a Vacuum Tech Certificate, which is just 9 to 11 credits, and it's focused solely on the Vacuum Tech courses that we offer here. So the point of the program is that it prepares students to work as technicians in industries or research organizations which rely on vacuum-based processes. Just a quick overview of the history of this program. It was conceived in 1996, so we're like 25 years past where the idea for the program came to be. And it was originated by collaboration with a couple of four or five industry partners to develop the program. It was Seagate, at the time VTC, which is now Polar Semiconductor, Cypress Semiconductor, which is now Skywater Foundry, and then Honeywell as well. And I'll just mention that those partners are still working with us today, so we really appreciate their commitment to this program. That's been essential. There's been a total of 4 National Science Foundation Advanced Technological Education Project Awards made to the VAC Tech program. The first one was in 2006, and then we've had a couple back-to-back, one starting in 2014. That one was called Revamp. And then just want to note at the same time, we were part of a larger Minnesota State Department of Labor TACT project that started at the same time. 2017, we were awarded the current project, Deliver. And then in 2020, we were awarded as a sub-award project to develop a VAC Tech ebook. The lead institution on that is a community college in New York. Also in 2020, the reason we got a no-cost extension is we were awarded supplemental money to support student undergraduate research experiences within our Deliver project. So briefly, what is vacuum technology? So vacuum systems are used to establish and maintain low pressure environments. So the little representation, this cartoon on the right has the enclosed space, which is representing the vacuum chamber, where the molecules of gas are not as dense as what is around the vacuum chamber, which is atmospheric pressure. So you create these vacuum conditions by removing the gas molecules from a contained space, and the intent is to create an environment which with molecular density that is much less than the atmospheric conditions that surround the chamber. So begs the question, why create a vacuum? And one of the key reasons is it's to increase what's known as the mean free path. And what that means, it's the average distance a molecule in the air is going to move before it has a collision with another gas molecule. So in air, the molecular density of gas molecules is really, really close. So they're bumping into each other very, very frequently. As you reduce pressure, that's a representation of the reduction of molecules. And so the spacing between the molecules gets greater and they bump into each other less frequently. So this little cartoon gives you kind of a demonstration of the bumping into the molecules as it transitions from one source, which I've called copper here, to some target plate. And the problem with trying to conduct this at under room conditions is that oftentimes the copper atom would not even get to the other surface, but there's also all sorts of other gas molecules that it can bump into and react with. And so whatever gets to the other side that you want to put down some type of metal is not what you intend. So again, I alluded to it in the previous slide, but the reason for increasing the mean free path is that it sets up a situation where you can do some very pure coatings of materials in a very thin layer of material on some target surface. So this cartoon illustrates that by removing a lot of those gas molecules, you create an open space that the pure copper can get from whatever the source location is to the surface that you want to coat more readily. So why is vacuum technology important? Well, as it turns out, this ability to put thin films down on surfaces is used in a wide range of applications. So there's a few of them on the right that really illustrate the kind of products that we know of every day that, at least in some part, came to be because they went through some vacuum process. So the image with the windows there, that's representing coated glass that has some type of a metal film on it for energy efficiency, or just for the aesthetics of the color that they can create. The sunglasses, kind of a similar type of process that is used to the glass coating on the windows. The computers and the cell phone, they are products of several different vacuum processes, from the electronics that are in each of those to the screens that have special coatings on them. And then we take it for granted, but the thermos is a really basic use of vacuum to maintain temperature of something within the center of the thermos itself. Here I'm just showing the core or summary of the core courses in the vacuum technology certificate. So as I mentioned in the earlier slide, our certificate is either 9 to 11 credits, and it really depends on what a person's background in math and science are, where they come into this. So for individuals that did not have as much math, especially to the level of an algebra and the basic chemistry, including gas laws, we like them to start with Foundations of Vacuum Science. So they cover the basic math and science that we need for them to really appreciate the concepts in the subsequent courses. Intro to Vac Tech is a course that focuses on kind of the basics of vacuum system design And vacuum analysis gets into the more advanced types of systems and the ways that you troubleshoot vacuum systems. And then thin film deposition is a course that's geared towards looking at how you use vacuum systems to do coating on substrates and then characterize the materials that have been coated on the surfaces. On this slide, I'm just trying to give you an idea of the different companies that we've worked with, employees that have come to us and taken our classes. Many of these are Minnesota-based companies, but there's a few notable ones that are outside of the state. We've had the pleasure of working with Lawrence Livermore National Laboratory in California. They've had a number of their technicians come and do some upskilling on vacuum technology with us. They completed the 3 or 4 classes and earned a certificate from California. So this is truly a distance program that affords some people an opportunity to finish a credential from anywhere. So just one last slide about the Deliver project. I wanted to kind of recognize all the different people that have contributed to the NSF ATE project. A couple of them have actually moved on, but this was kind of the core team that brought us to the point where we are today. I also want to acknowledge Steve O'Sell is our lab assistant, and he's here today kind of working in the background to help us with some of the setups. And I do want to give a shout out. Steve has been essential in helping us get some of this custom equipment that we're going to demonstrate for you today up and running. So with that, I think this is a good time. I'm going to transition to letting Tom lead on all the components we use to teach Vac Tech, but maybe Jason, if there's questions you want to have them asked now?
I sure can. If there's any questions, otherwise I can monitor the chat here as well. I offered up to the group if they would like to go ahead and ask any questions. We have time in the agenda, or we have some time right now if you'd like to learn more about the program. And you know what? I'm gonna throw one out there, Nancy. Here's a program. What, as you go through and get a certificate or graduate from this program, what types of pay are they looking for? Can they anticipate, or are you seeing recent graduates anticipate getting for pay? And what is predominantly the industry sectors that they might be working in?
Okay, great questions. So I'll start with the first one so that I don't forget. The pay, that's actually kind of a tough one to answer right now because in the pandemic period, some of the compensation levels have changed pretty radically. Prior to the pandemic, I think we were seeing on average a starting salary for one of the students with really no background was in excess of $20 an hour. Some of the industries, specifically like the semiconductor related businesses, Seagate, as I mentioned, Seagate, Polar Semiconductor, Skywater Foundry, they probably start the technicians somewhere between $25 to $30 an hour, something in that ballpark. Glass coaters, I honestly don't know what some of their starting salaries are, but I would have to imagine, at this point, most of them are closer to in the $20 to $25 an hour range. So.
And with that, is the job title a vacuum technician, or is it a technician and this is an accent upon their technician position? Is that what it is, or is it truly a specific job for vacuum tech, being a vacuum?
That's another really good question, and it depends on the business. So most of the industries we work with are hiring equipment maintenance technicians, and vacuum systems are one of the suite of equipment that they're responsible for maintaining. There are a few companies, I know Honeywell notably have designated vacuum technician positions. So it really depends on the company whether they have a specified position for vacuum technician. Most of them are generally calling it equipment maintenance tech.
Okay, awesome. Good. Are there any other questions out there? Opening the floor to ask Nancy some of the tough ones. All right. Well, with that then, Tom, go ahead and
Transition.
I'll let you take over.
Thank you very much. I'm Tom Johnson, adjunct instructor here in the vacuum technology program. I'm currently teaching one class per semester, and the class I'm teaching this semester is the thin film deposition course. And I'm going to give you a little bit of a flavor of how that course operates in our demonstration. But first, I just want to give you an overview of some of the strides we've made getting our program to work effectively on telepresence. So we were trying to do telepresence lab type training before the pandemic even started. So we were, in a sense, a little ahead of the curve on getting our technical type training out there. So with the aid of the National Science Foundation, we were able to develop several things, several key tools or instructional components that aid us in that method. So the first is just the general getting the information out to students that are remote. And we found the study guide to be a very effective tool as part of our pedagogy. And that just gives students an overview of everything they need to learn for a particular session. They can follow along, has all our lab notes and so forth. Number two is our learning management system, which is the same learning management system that's deployed across the whole state system. But so we use D2L, and that is another tool that we've developed and kind of built a structure around so that students can progress through the courses in a very logical manner. Number three is our telepresence classroom, and you're viewing our telepresence classroom right now. The cameras that are on me right now are part of our telepresence system, and I'll demonstrate that shortly. And then our vacuum equipment trainer systems. So our original vision was to, since we had these remote classrooms, is to make a vacuum equipment trainer that was portable or mobile so that we could deploy them in remote locations. And that would enable students to have the hands-on experience that we wanted to provide for them, even if they were in a remote classroom. And then finally, providing remote access. And I'm going to pause on that one and I'll come back to that. So here's our telepresence classroom and some different shots from the different cameras. But what I'm going to do is I'm just going to flip through some of our pre-programmed camera angles and just kind of give you a sense of how quickly you can change views and give the remote viewer unique perspectives on different parts of the lab. So this just shows the instructor front where I'm sitting. We have a camera in the back of our classroom. So if I want to present from this way and access the equipment behind me, a general classroom view. If we had local students here, we might use this view. Here's one of our trainer systems and a zoomed in view of the gauges in our vacuum chamber. More of an overview of that same system. We have a little more complicated system called our high vacuum equipment trainer. And back in the corner, we have our deposition system. And we're going to give you a little show and tell more on all these systems here shortly. So this is an overview of our simple rough vacuum equipment trainer, or actually our high vacuum equipment trainer, just a cartoon schematic model, kind of simplifies all that hardware that you just saw. And we've had grants that supported the development. We built all of these trainer systems internally with the help of students and with the help of our lab assistants, and a lot of hours went into the design and development and construction of these. So so number one is our rough vacuum equipment trainer. That is our basic system, just one roughing pump and a couple gauges, and Nancy will demonstrate that shortly. Here's our high vacuum equipment trainer. You can see it could be very intimidating looking at this and say, yeah, we're going to teach you how to operate and maintain this equipment. So we've developed a number of ways to make this, to break it down into simplified components that are easily understood. Here's our deposition system. And then we have a number of characterization tools. And this is the one I'm showing here is our thickness measurement profilometer system. So we bought this deposition system about 1.5 years ago, and it's been an exciting addition to our tool set. And I will demonstrate this shortly, but you can see that it has a PC as part of the system. And because it has a PC, we can share this in Zoom, and not only share it in Zoom, but we can also give remote access to remote users to actually push some of the buttons on the screen. And we thought that was such a great thing for distance learning that we decided to provide a remote access for all of our other trainers as well. And we've spent the last 9 months or so working on developing those systems as well. So we're going to demonstrate that, the rough vacuum equipment trainer right now, show you how that works.
This might be another good spot if there's any questions. Jason, if you have any questions in the chat that you want to throw out there right now.
I sure can, and I'm offering that up as well. If there's other questions that you have, please, you can go ahead and toss those in the chat. I can ask them for you. More than happy to do that. And so I guess my question for you is, as you walked your way through this, I noticed so many cameras that you put into there. Was that through recommendation of industry saying, look, I can't see what you're doing, or is there something else like that? How did those come about?
So it was less about the request from industry and more about taking the technology that was available at the time, kind of the best of the technology. It's a Cisco system, and it's made up of 3 cameras. And you can have pre-programmed views that allow you to just with a touch of a button, switch the camera, switch the zoom, switch the angle, and it even has speaker tracking, so you don't have to necessarily run the camera or direct. So if a student was asking a question, it would track to that student's voice and put them on camera. So very very cool technology.
Awesome. Awesome. Here's another question that we have in the chat. Do the electronic systems prevent learners from venting or other common mistakes?
And I take that one.
Sorry, can you repeat the question? I'm sorry, Jason.
Oh, sure. I sure can. Do the electronic systems prevent learners from venting or other common mistakes?
Oh, that's a great question. And maybe this is a good place to go into a demo too. Yes on some things and no on others, because some of the systems, it's maybe not such a bad idea for them to make the mistake if it's a safe space to make the mistake, because it'll really highlight the problem that is going to come in front of them if they put two valves on at the same time that they shouldn't. So we can maybe this is a good time to demo the rough vacuum system, because that's a really safe system to look at something like that.
Okay, that sounds good. And I will keep recording those more questions. Again, if you have questions, put them in the chat, and we can, like I said, we have time allocated for that discussion as well. So go ahead and do what you need to do.
Okay, so I am going to start sharing the control panel for our simple rough vacuum equipment trainer, and we've got it right in front of me here. This is a place where we would like to have a volunteer to help us demonstrate how this works. I don't know how we want to make a selection on somebody.
Steve, would you be willing to do that?
Yes.
Okay, so I am going to give Steve control. And Steve, now you should be able to move the cursor on this screen. And this has got very little limited control on it. It's just got valves that you can open and close, and then we can switch to a graphing. So go ahead and click on the valves. We don't have to worry about the pump quite yet.
Okay.
So we'll demonstrate the functionality. So this is a vent valve, and we'll kind of put it in perspective in just a moment. So go ahead and close that. And then click on the roughing valve right now. So we don't actually have the pump running, so nothing's happening. So we're going to go ahead and give you a chance to pump down this system. If you want to go ahead and close the roughing valve again. We're going to turn on the pump. This is kind of the loud part when we start operating some of these systems, so it can kind of overtake the audio. So what I'm going to do, turn on the pump, and then Steve, you can go ahead and open the roughing valve, and we're going to start roughing down this system. I will point out we put a marshmallow in a beaker in this system. This is one of the classic kind of demos for showing how when you reduce the pressure, if you've got something inside with a flexible contained gas volume, that pressure within the contained volume is going to try to equalize with the changing pressure around it, so it will expand. So I'm turning on the pump, and then Steve, you can go ahead and open the rough valve. And you can watch the gauges. We can give you a close-up. And so this is what our students in the remote locations would see, is they can see how marshmallow is expanding and it's taking up all the volume in the beaker. And then we point out a variety of things. Eventually it gets to a point where it stops expanding, and why does that happen? So you could, one of the activities we have in this particular class that we use, the marshmallow expanding, is we would have the students expand it, and when they see it gets to 250, then Steve, you would stop the roughing valve and it'd be like, okay, what pressure are we at when we got to 250 milliliters, so that they can, we do a kind of a gross evaluation of Boyle's law with this activity, P1V1 equals P2V2. So if you want to go ahead, you could also, open the vent valve, and then we show them what happens to the marshmallow. If you want to go ahead and close your vent, or your vent valve is closed, go ahead and rough again, open the roughing valve, and then go to the graph, select the graph. We've set this up so that students can see the difference in graphs that have a linear scale versus a logarithmic scale. And this is to try to give them some appreciation for why with vacuum systems, because we go over so many decades of values of pressure, that we like, or the logarithmic graphing is beneficial. So then they can also export the data to a file, and then that's used as part of the lab activities for them to do the analysis. So I think, can you go back to the display, Steve? Or, yeah, thank you. Okay, so one of the questions I think it was you that asked was, well, what happens if you've got roughing and venting going on at the same time? Well, this is a good one to try it out on. What happens? So we find out that the roughing, it doesn't go on very well if the vent valve is open, but that will cause our system to go back to the atmospheric pressure condition. So, and again, this is a safe system to make a mistake like that, so we can capture that kind of experience with this particular system. So I'm going to quit sharing. So Steve, if you wouldn't mind, you can close the roughing valve for us. I'm going to shut off the pump, and then I'm going to hand it over to Tom, who's going to do a demonstration with our deposition system.
So stand by for, we have some technical difficulties over here. So Microsoft decided to do an update.
Oh no.
After we got all the.
Okay, maybe can we do some questions now, Jason? We'll see if we can.
Well, we sure can as we're updating, and hopefully we recover from that update.
Well, I've got one. This is the way this is our real world as things happen. So do you want to do the profilometer first?
Yeah, we could do that.
So we're going to switch. This is going to flip our order. We were going to do the deposition, because usually that's the process that happens first, and then you do a characterization. But we can reverse it for today. So Tom is going to go in and show how you use the film thickness equipment.
Do you want to get Zoom going on this?
So we have, just kind of to narrate while Tom gets the setup in the other room. We have a small space in the back behind me that we have a couple of very basic characterization tools, and the profilometer is one of them. And let's see. Yep. So Tom is giving you the video feed of the profilometer.
Or you want to mute there? Hi, can you hear me? Okay, great. All right, so I am going to share my screen here. So I am standing in front of the profilometer. The profilometer is this device right here, and this measures the film thickness of a thin film. I'm going to load our sample. Okay, so what's going on here is we have a stylus that comes in contact with our substrate, and you can see a line. So you can't see. You can see a line on the substrate itself. This thin film is over here, and there's no thin film here. And we're going to drag this stylus across the step of where there's no thin film and there is thin film here. And because this is also a computer that's running the program, this can also be shared with a student remotely, so they can actually engage the and run the device from their computer. So I would just give them control, just like Nancy had demonstrated on the RBET. All right, so I'm going to hit engage. So the machine is going to take over and do the scan. And it didn't quite make it over the step. So I'm going to adjust that a little bit. But this is the kind of the output you would get, and you could measure the step height if it had gone completely over that. I'm going to get it a little closer. I'm going to re-engage. Okay, here we go. Engage. And hit scan. I'm going to level this data. So I'm moving the cursors to right before the step and right after the step. And then we can look at the height, and we got 584 angstroms or 58 nanometers. So that's how we'd get a film thickness from our thin film. And
So Tom, then my question for you then is, as you engage with industry members and teaching them how to use that, do you bring them over to it and you encourage that and help train them on how to use something like that? Is that how that works then, and allow them to run the controls?
yeah, so when we had students locally here in the classroom, they could have the hands-on experience by running the machine themselves. But now that we have computer and network access on this machine, we can actually have them run it remotely, and they can watch the process 10 times. They'll watch other students do it, but when they get to doing it themselves, it's a whole different story. And we've found that until they actually push the buttons themselves, the understanding doesn't crystallize. So here's the sample that I was just testing. It's a microscope slide with a thin film on it. And if you see, there's a blank spot in the middle, and that was where I was running the stylus over that step. All right, so I'm gonna stop sharing here. Did you get Zoom going on over here?
While you guys are setting up, can I ask a quick question?
Sure, that'd be great.
So I see the tripod. I'm gonna pin that picture. I'm trying to see it closer. So is that a GoPro or?
This is just a regular computer laptop camera.
Oh, okay. Yeah, it's kind of hard to see. Oh, okay, just the Logitech one, like I
Yeah, it's a
have.
Logitech, yeah.
Okay, no, I just like that setup. Did you guys make that with the long arm?
Yeah, so we just took a standard tripod and then we just attached this piece of structural material just to make an arm so it got into the right position.
Okay, I really
I
like
could
that.
hold it with my hand, but yeah, then you get the jittery, shaky motion.
Oh, definitely. Because I
So-
build PCs in my classes and I just did it last night with my students, and a lot of people couldn't make it because their kids, made them quarantined or something. So I could have done something like this. It's just, I was thinking about strapping the GoPro to my head. Thank you.
You're welcome.
And then Nancy, do you have time for another question?
Absolutely.
All right, I'm assuming you're using turbo pumps and ion pumps. Is there any use for learning oil diffusion pump technology?
Yeah, that's a really good question. So if you're working in semiconductor, you're not going to see oil diffusion pumps anymore. They tend to add more contamination into an environment, so there's the turbo pump is the preferred kind of first level high vacuum pump. There are a lot of manufacturers, though, that don't require that same level of cleanliness as semiconductors, like the glass coaters. I understand they've been migrating more to turbo pumps, but a lot of them still use the oil diffusion pump. And then we just inherited a cathodic arc system, which is a really quick system for putting down titanium nitride on tool bits. And my understanding from the person that donated the system is the diffusion pump is still the primary pump for those systems. So I think it's worth covering diffusion pumps because the basic mechanics of it are kind of an easier thing to learn, and maybe are a good stepping stone to the turbo pump anyway. And since they're still out there, I think it is worth covering the diffusion pump still. Does that answer the question?
Yes, I think so. My next question would be, is there a significant cost difference between those?
Yeah, diffusion pumps tend to be cheaper, much cheaper.
And throw me in a ballpark of those of us that aren't in that industry, what's the cost?
That would depend. I'm going to throw Steve. Do you have any recollection for the?
I never was involved with purchasing a diffusion pump. That was somebody else's responsibility where I worked. But
well, and turbo pumps.
In leak detectors too, they had some diffusion pumps, but they pretty much phased out diffusion pumps and went with thermomolecular pumps.
Yeah.
Okay.
We're going to. Tom's ready with this setup, so we're going to give it over to him for the sound. So I'm shutting off our room sound, and he's going to pick it up on his computer. Jason, is Tom, or is the deposition a co-host?
Let me look.
Oh, you need to reset it because he rebooted. So if you could give him co-host, that'd be great.
Yep, happen right now. All set.
Share my.
Okay, can you? All right, so what you're seeing on the camera is looking inside the vacuum chamber, and there's not much to see right now, but I'm going to start a deposition. So you can see that this deposition system uses a vacuum system just like we saw demonstrated by Nancy. Same types of components, just laid out a little bit different on the screen. So it's already pumped down to 1.6 times 10 to the -6 torr, which is a very high vacuum. And then I'm going to deposit some copper on that microscope slide by running a recipe. And this is all automated, and this is what students would find in industry as a system like this that would automate the process just by pushing a couple buttons. Right now, it's setting up the correct pressure for the system. And I'm looking down at this pressure control right here, and we're trying to get to 15 millitorr. We're using a sputtering deposition technique. So we're going to be creating a plasma inside the vacuum chamber. And that plasma is going to vaporize our source material, which is our solid copper target. And then that vapor is going to be deposited on our microscope slide substrate. So if you're looking down inside the chamber, you would see this source in the that I'm pointing at that has a copper target. Right now it has a shutter over it. And then we should start to see the plasma here in the camera. As soon as the shutter opens, it'll be a little more visible. It's warming up, it's counting down 60 seconds here. And when that time is elapsed, the shutter will open. We'll start our deposition. And then I will stop sharing the screen here when it starts. And so you can see my video feed a little larger. All right, 10 more seconds. Okay, the shutter is open. And you can see the plasma inside the chamber and our microscope slide that's rotating up on top. So it's a sputtering up deposition. So the source material is down at the bottom of your screen, being vaporized and then being deposited upwards onto the microscope slides. This particular system has a thickness monitor. So if you look on the on our control screen, we can monitor the thickness being put down in real time. I had chosen to deposit 1 kiloangstrom in this process run. So we've already deposited about half of our thickness. And the system, once it gets up to 1 kiloangstrom, it will shut down automatically and turn off all the process gases and the power, and then we'll be done with our run.
Hey, Tom,
it does look like we are at the end of our time here. So this is the exciting part of the deposition. So that maybe we will field any questions at this point. And
yeah, Tom, I guess I would like to ask you, how does when you're working through this and you're dealing with industry and industry training and industry certifications, is it are you able to hear me, Tom?
Okay, we switched our sound and mic over, Jason. So can you repeat your question for us, please?
Yep. You know, one of the things that we've been really driving towards is pedagogy and the pedagogy of, you know, it looks like you're dealing with a lot of high-tech instrumentation. And And with that, how are you using that to teach industry members? And what are some ways that you can speak about what that pedagogy is that you've found in working with this equipment that has been successful? And you know what, I want to find out some failures too, because not everything is a win. So talk to me about pedagogy and training, if you would, please. All right.
So I can
Go ahead.
field that. So what we found for best practices is first making sure all the remote students have access to all the course materials. So we've spent some extensive time and put a lot of thought in our course design on our learning management system. And then what I had alluded to earlier was we have study guides that go with every class session that have the learning objectives clearly laid out for that session. So everything we want them to know coming out of that class session is stated on there, and they can follow along with the lecture and the labs and fill in the blanks. It organizes their notes. And we've just found that to be very helpful. Then they can use that to study for their quizzes and their exams, that same material. So if they know what's on those study guide sheets, there's no reason why they wouldn't ace any quiz or exam, because we've told them what they need to know coming out of that. So that was key pedagogy number one. And the second one is getting the hands-on training. So making these trainers available, first of all, to make them literally hands-on, but then secondly, virtually hands-on, not only gives the students a tactile user type experience, but it also breaks up the lecture a little bit. So you can do some lecture, do some activities, go back to the lecture, do another activity, and that really, I think, enhances the attention of the remote student, because you're mixing it up a little bit. You're not doing 3 hours of solid lecture. So those were my key takeaways. How about you, Nancy? Do you have any?
I will, I guess, emphasize that this program used to be much more lecture-based and information sharing, but over the course of having the NSF AT projects, we've really gravitated and moved to doing much more active kind of learning in the classroom. So even the problem solving and how we're actually using the mathematics that we want them to understand and be able to apply. We spend time in like small group breakout sessions, having them practice some of the problem solving. Those have been really key developments, I think, in the approach we take to teaching these classes.
Good, that's awesome. Are there any questions from the group here? Otherwise, I've got a couple more questions for them. Any more?
I had a question. So for assessments, do you do hands-on labs then? If you're in a teleconference situation, have you ever considered like group projects or having Zoom sessions where students work together and you give them remote control to actually do the lab, give them a final project lab or a group lab, and you get 3 or 4 students on the teleconference so they can actually do these, give them remote and do this?
That's an excellent question, and I'll actually set this up for Tom to respond to. is part of the supplemental award that we received last year. We had the opportunity to develop a kind of a pilot class where we are allowing the students, I should go back to the rough vacuum trainer system that you saw, the interface that we shared with Steve, that was developed by a student. This pilot class that Tom taught was all about allowing the students to develop software and demonstrate how it works. So can you talk a little bit about what you did with the pilot class?
Yeah, thanks for that question, Michelle, because that is one of the learning outcomes that I've learned by presenting this type of experience, is that the breaking out those lab experiences into smaller groups and having just 3 or 4 students at a time come into the Zoom session and do the hands-on virtually, and then giving everybody a chance to push the buttons. It both stimulates, the intergroup conversation. It's not now just watching somebody do it. It becomes very experiential. So yes, so we did find that smaller groups doing the lab type activities works best.
But did you create an assessment around it? I'm just wondering if you did it like a graded assessment around that yet.
So the assessment was the lab report that comes out of that experience. So they have to take the meticulous notes to document the process and then turn in a formal lab report of basically how did you do it and what were the outcomes, and did it match what you thought your hypothesis was, and why or why not. And so standard lab report format. Yep.
Oh, love that. And was it a group effort, a group, so you assessed on the group, or did you assess individually?
So I assessed individually. Everybody turns in their own lab report. I just think everybody needs that skill individually, and could turn that in. But also with the distance learners, they can't collaborate in the same room like they used to be able to. So it's not easy for remote learners to connect with each other. So haven't really overcome that obstacle yet.
Thank you.
All right, I've got a question here. Does your program emphasize NI LabVIEW instrumentation?
So that's a really interesting question, good one too. We do not. The platform that we used for the software control of these systems is DAC Factory, and with the data acquisition hub is LabJack. And Tom, do you want to talk a little bit about those two elements?
Well, we chose LabJack as our data acquisition hardware controller just because they were very inexpensive, and if we ever decided to have the students purchase them for themselves, they were affordable. And then there's a third-party software that allows the development of the human-machine interface called DAQ Factory, DAQ Factory, and that works with LabJack as the software interface, and it seemed to work. And it has its limitations, of course, but we've been able to pretty much get it to do whatever we wanted it to do as far as machine control.
Awesome. Thank you very much. I'm going to throw this question out there. The whole time I kept watching this, I kept wondering, This is the equipment that you have to operate. How do you make that analogy to an industry or an industry member out there who has completely different looking equipment? Does it all kind of operate the same, relatively the same, or when you're training industry, do you have them give you an overview of this is our equipment, this is what we look at, this is what we interface with, and then you adapt your pedagogy to help them understand how they can make that quicker connection to their equipment? So I'll ask you that.
So I'm thinking like a biology lab. How do you get a biology lab experience remotely? Of course, they've had the kits sent out to each user, and you can kind of do things at home. But there's some equipment like a scanning electron microscope. Not everybody's going to have one of those in their home, or willing to purchase one, at $100,000 a unit. So you need to bring that equipment to the user in their home virtually. And there's no reason why you couldn't connect a scanning electron microscope up to a Zoom session with that computer interface. I don't know if there's other examples.
I guess the question really ties into when you do industry training and industry certifications, you'll use your equipment, but do you reach out to that industry when you're doing industry certifications, training their employees? Do you review what they currently have for equipment going into the training process so then they can make a quicker connection?
So I'm just going to jump in on that. Is we are offering Normandale's academic certificate to the industries that have been sending their employees to them. So we are not customized. We haven't customized to any particular industry's equipment. And, our experience has been with the vacuum world, the vacuum systems are always custom to each of the employers anyway. So what we're trying to achieve is we're giving them the foundations of what a vacuum system is, what a person that's going to be working with a vacuum system should expect, and some of the principles of how they operate, some of the variables they might find in a system, but then they will learn the very detailed kind of operational information from their employer. We provide the foundation for how a vacuum system operates and why it operates the way it does.
Okay, good. And so any other questions from the group?
Okay, I have one more. Have you ever considered using Oculus, virtual, the VM, or the, not virtual machines, but I'm sorry, I'm doing two things at once right now.
That's an excellent question, Michelle. I guess considered it. Again, we've made a fairly significant investment at this point in this remote access. And our observations of other VR systems are, well, one is the cost of them to get all of the detail of operation that is fairly easy to achieve with these remote access systems because it's a real system. We don't have to go in and then simulate it into the VR world. We can just create, some condition pretty readily with any of these systems and then make it happen for the user. That being said, I think that will be a technology that's going to be part of the toolbox in the future. So, we'll keep our eye on it. Are you using VR?
No, but we've been talking about it, especially in our biological sciences program. So it's just interesting to see if anybody has tried it across Min-State.
Yeah, I don't know of a Min-State institution, but I am aware of another NSF ATE awardee project that's doing VR. And they're doing some really interesting things. And it does kind of get more towards training people for particular equipment in a lab. So before you would bring someone into a kind of a clean room space and, you know, try to go through the logistics of getting them in there to do something right on the equipment, they run them through a VR kind of a process to go through a sequence of operations before they get in front of the real thing. So I have seen some examples of how that's starting to be used.
That's something I'd like to explore a little bit more for the future. Like you said, it's something that might be in our toolbox in the future, how things are going right now.
Michelle, there's what's interesting is I believe Southwest State is doing some venturing into utilizing that virtual reality content of delivery in their veterinary science classes, of all things. So I saw a presentation on it, helping with students understand, you know, timing wise for an animal birth, it never happens when they need it to happen. So they've actually, it sounds odd, but Marshall at Southwest State in their animal science class has been doing that. So, and hopefully, you know, we start seeing more of that, especially in these training opportunities, non-credit side of the academic institutions, to be able to keep some employees up and where they need to go. And very much to your point, hopefully we'll be done with this going into the spring, but I think we just need to be prepared. And I think this provides an opportunity to us be worldly. And I think we need to start thinking worldly and not just in our little zones here. So great concept, great discussion, and great thought process into that. So any other questions that you'd like to ask? We have a few more minutes here and like to offer that up.
Do we have more than one person from MSUM? Because I'm wearing the dragon shirt right now. I'm Century College, but I'm a student at Minster. Yeah, there's Steve. Okay, I just had to say go Dragons. That's about it.
Dragons, that's good. Ah, jeez.
Sorry.
That's all good. All
Hey,
right.
I'm not, I work at Century College, so.
It's all good. All right. Go ahead.
Jason, maybe we could put one of the participants on the spot a little bit. One of our organizational contacts is Skywater, and Matt Ragnerud is on the, and I apologize, Matt, if I pronounced your name incorrectly, but he's on this session, and maybe he can tell us a little bit about what Skywater needs for their technical staff and employees.
Right, that would be great, Matt, if you could share some of that information.
Yeah, sorry.
It's all good.
Going on quick. Hi, Matt Rogner. I'm equipment operations manager here at Skywater. I also spent 13 years at Polar, so I've known Nancy and the program for quite a while. We're looking for techs. We would take a tech out of the program because, as people probably are aware, like the entire in manufacturing is really short on skilled labor and people that fit it into a semiconductor role here as a technician at Skywater. So we'd take any of those technicians. We were looking for, vacuum. I've had the vacuum systems for quite a while on ion implant, and I am also doing PVD here at Skywater. But also the other thing I'm very interested in is sending out some techs for training, because the majority of technicians we have are more of electronic technicians or mechanics. We're still trying to have a broader net, so we're having some people with car maintenance or automotive techs or anybody else we can bring in that don't have any vacuum experience. I'm trying to get them out to a program at Normandale to just beef up their vacuum skills. But like I said, we're really trying to hire hard, and I know Polar is also having a hard time getting technicians.
Hey Matt, let's talk about this. Help me out with the good paying jobs, average jobs. Help me out with that. What are you seeing from that aspect of relative to other groups in industry that you're seeing in your sector?
Yeah, the jobs. One of the problems hiring technicians right now. They're in hot demand all over the Twin Cities area. So pay is going up from what it's traditionally kind of been at for the last couple of years. But I know when we start getting into how much we're going to pay somebody to come over to Skywater, it's getting tough. Yeah. Right. So I'd say pay is probably going to increase here.
Right, and chasing after them. Yeah. Well, good. Well, thank you. Thank you for your contribution,
yeah.
and thank you for being online and helping out with the Normandale team here as well. So always happy to have an industry representation connection on these events. So thank you.
Yeah, and I know Nancy knows historically it's been a few years now, but Seagate and Polar and at the time Cypress have done just one-off classes with just people not trying to go through the whole course, but just get a bunch of technicians together and just do a course for people already employed in the industry, right? So I'll talk to my counterparts and see what we can do.
Awesome. Well, very good. Thank you.
Thank you, Matt.
Thank you.
As in parting words, Nancy, Tom, what would you like to people to take away from a learning process standpoint here? And I know you shared some great best practices, the importance of good coursework, good course material, the importance of a study guide, learning objectives, which I really love that you made that comment, Tom, as well. The importance that everybody knows what's going to come out of it, and this is what you should understand when you come through. Hands-on training and that opportunity with this virtual remote experience as well for these industries, and breaking that up, like you had mentioned earlier, discussed earlier, that discussion between lecture and actual hands-on activities. So good stuff with that also, and active learning and problem solving. Small breakout groups always seem to help with that, especially this virtual kind of stuff. So it's when you can induce that training or teaching happening amongst those little groups, that's great. So anything else you'd like to end with?
I think you did a great job summarizing all of the important points that we've been trying to develop for ourselves in the way we deliver this curriculum. It's a journey.
Yeah, and it looks like it was. And thank you so very much for sharing it and sharing your information, and giving us your time and your talents and showing us your time and your talents as well. So I thank you for Normandale College. I think the acknowledgement also in there is NSF as well as acknowledged in there also. And a reminder to those here to be a survey going out, help us better support you and support some of the learnings that you would like to have. And the video of this event will be available on our website. And if you're looking for that professional development time, go ahead and contact me, jason.bruns@mnsu.edu. And if you want to look at our next meeting, mark your calendar, February 24th of 2022. Who knows it'll be, but we're going to come up with something, and I think it'll be, and hopefully you'll have some enjoyment out of it. So I'm going to wave off to my Normandale team, and I'm going to close out from there. So thank you very much, and I hope you have a wonderful rest of your day. And I kept thinking,
Yep, thank you.
And I need, let's see, can I get control here?
I paused the recording. Well, it looks like it's still recording, Jason.
Yes, I would like to share this final screen.
Okay, sorry.
Oh, it's all good. And that. All right, I'm gonna stop. Yeah.